Samples are important in research because it would be impossible for us to ask the entire population, whatever it is that we're interested in researching. So we use them to make inferences about populations. Samples are easier to collect data from because they're practical, they're cost-effective, they're convenient, as well as manageable. So in research design, population and sampling are important terms. A population is a group of individuals that share common connections, and then a sample is a subset of that population. The sample size is the number of individuals in a sample. The more representative the sample of the population, the more confident the researcher can be in the quality of the results. An example here is you can read, if you want to get an idea of how people in general feel about a new pair of shoes you just bought, we can't ask everybody, what their opinion is, but we can randomly select 20 people throughout the day and ask them, what their opinion is. So we're making inferences about the population of interest and only asking the 20 people, which is your sample size of the general population that you come across throughout the day. Most of the research today, when we use the term participant, we're describing a human. That's not the case in research if you're reading it from a decade or more ago. You might see a subject referred to as a human, but we've switched the language in more recent research. But typically participants are human based today, and subjects would be considered animals or non-human participants today. Usually humans are voluntary, they're willing, they're actively participating in the study, they can communicate with the researcher, they can provide informed consent. More importantly, the person as a whole is studied. Their perceptions, their beliefs, their opinions, experiences, or some aspect of mental or physical ability. Subjects usually describes the person or thing that is the topic of the study. Subject can be used to describe non-humans, such as plants, animals, minerals, or machines. That's why typically non-humans, a lot of researchers will protest the use of the term in human research, as it implies that the person has limited autonomy or was not actively involved in the study. So sometimes when we're doing like a review of previous literature, a retrospective analysis, if data was collected under non-research conditions or is being analyzed for research purposes, and we might be more likely to use the term subject. Something along those lines is typically, if you see the word patient in something, then it's typically medical related or a medical condition that's being investigated or studied. When we look at the target population, that's the total group of individuals from which the sample might be drawn, right? So whatever the group of people is that the researcher is interested in studying. So if we're looking at students that are choosing a college, we can't obviously reach out to all students that are interested in choosing a college, but we can find an accessible population by sampling students that are in high school that are looking to go to college, right? So we would select high schools and go from there with our collecting our sample population. So we want to, look at different characteristics. Maybe we're looking for a target population or a accessible population for students that want to attend a university, or students that want to attend a local community college or a private institution. So we would decide first what type of college, we're looking at, and then decide what our target population is. An accessible population would be from there. So for the representative sample, a subset of population is what we would seek to accurately reflect the characteristics of the larger group. So if we had a classroom of 30 students and we had 15 males and 15 females, we could generate a representative sample that might include 6 students, 3 females and 3 males. So samples are used in statistical analysis when population sizes are large because they contain smaller, manageable versions of the larger group, right? We're taking a representative sample of the 30 students that are in the classroom and only using 6 of them, rather than trying to work with a larger number of 30. So, when we use sampling, as a statistical analysis methodology to try and gain insight and observation about a population group, we can use these sampling methods to build samples that seek or try to meet the goals of the research studies. And representative samples is one type of sampling method. This method uses a stratified random sampling, and it helps to identify its components. So other methods can include random sampling as well as systematic sampling to try and get a select amount of participants. And then we have probability sampling and non-probability sampling. So probability sampling is a type of sampling that ensures each subject of a study has the same likelihood of being selected. The goal of probability sampling is to get a sample that's representative of the greater population. This way we can try to generalize the results of the study to a larger group of people. We often use this in quantitative research, again with the statistical analysis. It helps to give us more, generalized results for a population of interest. Researchers use this to select people for a study at random. When they use probability sampling, this is more likely to produce objective or unbiased data. Sometimes we do simple random sampling. This is where researchers assign each member of the population a number and then use a random generator or some selection technique, random selection technique, to get the selected number or desired number of participants from the entire population. Kind of like drawing numbers out of a hat, right, at random. Something else that would fit underneath the probability sampling would be the stratified random sampling. And this would involve dividing your population into different subgroups proportionately by categories such as hair color, eye color, and then you take a single random sample from each subgroup. Sometimes stratified random sampling helps you ensure that you're proportionally representing the entire sample and important subgroups of the population. Stratified random sampling may have higher statistical accuracy than a simple random sample because you're taking specific subgroups into account. And then cluster sampling also goes under this, but there's another slide that'll come up, so we'll talk about that in a few minutes. And then the non-probability sampling is a category of sampling that we use in qualitative research. And this includes non-random deliberate process for selecting participants. So the results are not typically used to create generalizations about a particular group. So the non-probability sampling involves the intentional selection of certain participants to gather information about members of a specific group or people with specific insight into a particular area. Non-probability sampling is useful in conditions where you may not have access to an entire population to conduct random sampling, or if the researchers are interested in participants who have a certain area of knowledge or expertise. Non-probability sampling can be useful when seeking ideas, or if we're gathering public opinions about a topic. Sometimes we do the purposive sampling. This is when researchers who have a definitive purpose in mind are seeking specific predefined groups. Market researchers often use purposive sampling to receive input and to get feedback from a specific population about a particular service or product. Purposive sampling may be useful when proportionality isn't a concern, and instead you're hoping to reach a targeted sample of a population quickly. So, a new, brand of Doritos comes out, right? Or a new flavor comes out, and they want to know what people think of it. So we might use a purposive sampling to get the feedback from people to see whether or not this is a, you know, quality of taste or what people think of the flavor of this new brand of Doritos. Snowball sampling is another one that falls under non-probability. And for this, you rely on participants in your study to connect you to other potential participants. You can begin with one or several people who meet your study's criteria, and then you ask them to put you in contact with other people they know that may also fit this criteria. This is particularly useful if you're sampling a population and you're finding it hard or difficult, challenging to contact other potential participants. Ethnographers sometimes or other social scientists use this if they're studying populations that are recluse or can be inaccessible. So that snowballing technique can be helpful for that. Convenience sampling is another one. Researchers can create a convenience sample by selecting people that are easily accessible. They're willing to take part in the study. It's a great way to gather initial data for a study. It can require less effort than other sampling methods. You can consider using a convenience sample if you want to gather opinions about a particular topic and you have a limited amount of time or resources. So those are some other types of volunteer sampling. You can use probability sampling and non-probability sampling when you conduct a study, but it's important to understand how these two categories differ. So use in qualitative or quantitative research. Researchers often use probability sampling in quantitative research because it's more statistically accurate, and non-probability sampling in qualitative research because they can use it to generate ideas or receive participants' feedback and opinions. Randomization, researchers find participants for a probability sample at random, so all members of a population have the same probability of being selected for the study. Alternatively, researchers deliberately find participants for a non-probability sample. And then relationship to the hypothesis you want to keep in mind. In probability sampling, the study's goal is to test a predetermined hypothesis, whereas in non-probability sampling, researchers generate the hypothesis after they collect the data from the participants, because that's what happens in a qualitative study, right? There's no hypothesis to start the research. The hypothesis comes after you've collected all the research and information. So when you create research, you want to keep in mind what type of sampling you're doing and whether your research is quantitative, qualitative, or mixed, because you have to identify what type of sampling method you're using to collect the data in your research study. So I mentioned a little bit of convenience sampling in the last slide. I see a lot of students, when they put their research projects together, do convenience sampling because just that, it's convenient, right? To use whatever research participants might be easy to access. But convenience sampling falls underneath a non-probability sampling, which would put your research projects underneath a qualitative study or perhaps a mixed methods study. So depending on how the research is being set up would determine whether or not a convenient sampling would be, easy to use or accurate to do. So keep that in mind, as you're putting your research projects and things together on whether or not a convenient sample would work for what it is you have going on. So quota sampling is another non-probability sampling technique that targets a population of interest. It stands in contrast to probability sampling methods like simple random, which uses a random selection to pick respondents from the whole population. Whereas all members of a population have an equal chance of getting picked for a study that uses random sampling, the likelihood of getting picked for a study that uses quota depends on whether they have certain characteristics. So in this way, quota sampling intentionally displays selection bias towards specific groups. It's a popular technique in survey research. Quota sampling is used when researchers want a representative sample of a target population. So for example, in quota sampling, if a shoe company conducting market research for its new athletic sneakers, they have years of sales data already identified its core customer demographic. They've got men in the 18 to 25-year-old range. They have an average education level ranging from high school diploma to bachelor's degree. And thanks to the detailed accuracy, the shoe company can develop a quota sampling methodology to gauge these young men's impressions of its new sneakers. By limiting its sampling frame to people known to engage with its product, the company streamlines its data collection and can better target its forthcoming marketing campaigns. In this scenario, and many others like it, the quota sampling method saves researchers time and resources as they seek a final sample to study. So they picked the sampling frame, and narrowed it down from the quota sample, which is what helped them focus on that specific, age or demographics that they chose. All right, so going back and revisiting the simple random sampling, we can do this with and without replacement. Sampling with replacement is when we have members of the population that can be chosen more than once for inclusion in the sample. So let's say we have 100 names. They're all written down on a piece of paper. All of those pieces of papers are put in a big fish bowl. We mix them up. The researcher picks a name from the bowl, records the information to include that person in the sample, but now that name gets put back into the fish bowl, mixes up the names, and selects another piece of paper. The person that was just sampled has the same chance of being selected again. This is known as sampling with replacement. Sampling without replacement is a method of random sampling in which members of the population can only be selected one time for inclusion in the sample. So same example as before, we put 100 pieces of paper, in the fish bowl, mix them up, randomly select one name to include in the sample, but this time we don't, we record the information, but we do not put that name, that piece of paper, back in the fish bowl. We set it aside. And so in this example, each person can only be selected one time. There can be a lot of advantages and disadvantages to using stratified sampling. We have, a couple different ways, proportionate and disproportionate outcomes when it comes to using the stratified method of sampling. First we have to classify the population into groups, right? When we do so, we call this stratification. But the strata must be mutually exclusive, and all members of the population can only be in one stratum. Researchers tend to use this proportionately when they try to represent the population as a whole. So we often do this when studying polling of elections, population demographics, life expectancy, if we're studying income in varying populations or income in different jobs across the nation. When the samples of a population vary drastically as forming the strata, this can help to organize a group of people. But when we go to identify or form the stratified sampling, we first have to define the population of interest, choose the characteristics that's going to help divide the groups. Then we can divide your sample into the strata depending on the relevant characteristics, but each strata must be mutually exclusive, but together they must represent the entire population. You have to define the sample size for each stratum and decide whether your sample would be proportionate or disproportionate. The size of the sample in each strata should be ideally Should be in proportion to the members of the group within that target population or sampling frame. And then you'll want to draw a random sample from each stratum and combine them to form your final stratum. It's very efficient and manageable. You can organize a population into groups with similar characteristics. Researchers often save data collection time. They can better manage a sample that would otherwise be too large to analyze. The costs to do this are often cheaper with this method of sampling because there's minimization, right? The researchers are saving money by dividing the large population into smaller groups. Oftentimes there's more accuracy. Stratified sampling can produce more precise estimates than the simple random sample because the members of the subpopulations are relative to the entire population, so it gives you or the study a more statistical power. But the disadvantages, there's a lot of differences within the population. So a population can't be organized into subgroups if there's too many differences within that population or not enough information about the population at hand. Researchers must ensure that every member of the population fits into only one stratum and that all this information collectively contained for every member of the greater population. This involves extra planning, information gathering that the simple random planning or sampling doesn't require. Sometimes there can be sampling errors that can occur when the sample does not end up accurately representing the entire population. If this occurs, the researcher would need to restart the sampling process. Some examples of this stratified random sampling is investigating the relationship between average travel frequency, trip mode structure, and the characteristics of residential areas. Another one would be examining the prevalence of psychological problems of childhood sexual and physical abuse in adults from the general population. Studying perceptions of drinking water quality at 4 locations in any given country. Any country you'd want to choose. You could evaluate the usefulness of personality traits in the explanation and prediction of entrepreneurship. Those are just a few examples of studies you could do or some that have been done. Systematic sampling is a type of probability sampling in which a random sample method is done with a fixed period interval and it's selected from a larger population. This fixed periodic interval is called the sampling interval. This is calculated by dividing the population size by the desired sample size. An advantage of this methodology includes eliminating the phenomenon of clustered selection and the low probability of contaminating data. Disadvantages include over or underrepresentation of particular patterns, and there's a greater risk of data manipulation. It's popular with researchers and analysts because of its simplicity. Researchers generally assume that the results are representative of most normal populations, unless there's a random characteristic that's disproportionately existing in the data sample, which is unlikely. In other words, population needs to exhibit a natural degree of randomness along with a chosen metric. If the population has a type of standardized patterns, the risk of accidentally choosing very common cases is more apparent. An example, as a hypothetical example of systematic sampling, you would assume that in a population of 10,000 people, a statistician selects every 100th person for sampling. The sampling intervals can be systematic, such as choosing a new sample to draw from every 12 hours. As another example, if you want to select a random group of 1,000 people from a population of 50,000, you use systematic sampling. All the potential participants must be placed in a list, and a starting point would be selected. Once the list is formed, every 50th person on the list starting at the selected starting point would be chosen as a participant, since 50,000 divided by 1,000 equals 50. For example, if the selected starting point was 20, the 70th person on the list would be chosen, followed by the 120th, and so on. Once the end of the list was reached, and if additional participants are required, the count loops to the beginning of the list to finish the count. Systematic and cluster sampling differ in how they pull sample points from the population included in the sample. Cluster sampling breaks down the population into clusters, while systematic sampling uses fixed intervals from the larger population to create the sample. Systematic sampling selects a random starting point from the population, and then a sample is taken from regular fixed intervals of the population depending on its size. But the cluster sampling divides the population into clusters and then takes a simple random sampling from each cluster. Cluster sampling, though, is considered less precise than other methods of sampling. However, it may save costs on obtaining a sample. Cluster sampling is a two-step sampling procedure. It may be used when completing a list of the entire population is difficult. For example, it could be difficult to construct the entire population of the customers of a grocery store to interview. However, a person could create a random subset of stores, which is the first step in the process. The second step is to interview a random sample of the customers of those stores. So this is a simple manual process that can save a lot of time and money. Cluster sampling and systematic sampling differ, like I said, in how they pull sample points from the population included in the sample. But cluster sampling is susceptible to a larger sampling error than systematic sampling, even though it may be cheaper, to complete the process. So the sampling error versus the standard, standard error of the mean. The sampling error is the error that's incurred when the statistical characteristics of a population is estimated from a sample of the population due to the choice of the sample. As a concept, this is distinct from the standard error, which you understand correctly. The standard error is an indication of how close the sample survey estimate is to the result that would have been obtained from a census under the same operating conditions. The standard error only gives a measure of the variation in values obtained from repeated samples. So the greater the sample standard deviation, the greater the standard error, or the sampling error. The standard error is also related to the sample size. The greater your sample size, the smaller the standard error. So there's a relationship between sampling error and standard error. The difference is that a sampling error is a specific instance of inaccurately sampling, such that the estimate does not represent the population, while a sampling bias is just a consistent error that affects multiple samples. Like one sample would have bias not indicating the true population data for eating habits. When a population is sampled, the mean or average is generally calculated. This spread is most often measured as a standard error, accounting for the differences between the means across the data sets. So the standard error of the mean tells us how accurate the mean of any given sample from the population is likely to be compared to the true population mean. When the standard error increases, the means are more spread out. It becomes more likely that any given mean is an inaccurate representation of the true population mean. If we look at the difference between the sampling error and measurement error, the sampling error is much harder to measure directly. You might expect that the sampling error would shrink as the number of samples approaches the size of the population, whereas a systematic measurement error would remain approximately the same regardless of the sample size. So if we look at the relationship between standard error and standard deviation describes variability within a single sample, while standard error describes variability across multiple samples of a population. Standard deviation is a descriptive statistic that can be calculated from sample data, while standard error is an inferential statistic that can only be estimated. There are some similarities between standard deviation and standard error. They're similar in that they both estimate variation. The standard deviation, or SD, is an estimate of the variability in the population from which you sampled. The standard error, which would be SE or SEM, is an estimate of variability in the theoretical population of means. If we look at the relationship of sample size and standard error effect on the distribution, the standard error measures the dispersion of the distribution. As the sample size gets larger, the dispersion gets smaller, and the mean of the distribution is closer to the population mean. This refers to central limit theory. The sample size is negatively correlated with the standard error of a sample. All right, so that is going to wrap up this slide. Goes a little, I know I went into a little bit more detail than what you have here, but just to try and give you a better sense, because I know some of this sampling error and standard error can get a little bit confusing. So I went into sampling bias a little bit on the last slide, but for any type of survey research, the goal is to get feedback from people who represent the audience that you care about, right? Or in statistical terms, this is your sample that we're talking about. Sampling bias occurs when you only get feedback from a specific portion of your audience and you're ignoring everybody else. This often occurs because a customer segment's left out of the survey process and may have not been invited to even take your survey because you don't want their, thoughts on it. So if we are only contacting certain people or certain distributors or certain customers, we're essentially doing sampling bias and only getting a specific group of individuals to fill out that survey. If we want to reduce sampling bias, we need to take a few steps back and ensure that the survey is designed, the whole process is, going as it should, and that we're not leaving a specific group out. So, you need to figure out who it is that you want feedback from. What is it that you're trying to gain from the survey process, so that you can get the answers, that the unbiased answers that you're looking for, right? And so this is most likely going to happen in your survey distribution method, making sure that the timing makes sense for the people that you're emailing it to or sending it to, so that everybody has access to it and that everybody is receiving it. Non-response bias is, in some ways getting people to respond. Even if you've included your entire core audience in the survey, there's still no guarantee that they're going to answer, right? When we do, research and we send out mailers to thousands of people, we don't get thousands of responses back, right? There's a lot of inactive users or participants who may not be as likely to respond. We see this a lot in longitudinal studies. We lose track of people. People aren't interested in staying a part of the research, and so they're less likely to respond. And so they might not be giving any feedback, or, you might not even have ways to contact them anymore, right? So there's some non-response bias information that you're getting. So sometimes timing, you can try and adjust survey timing to try and get better results back, keeping surveys short, try different, survey distribution methods to help reduce non-response bias. that can all help to try and improve the results or the, return and surveys that you're sending out. Many of the colleges and universities across the U.S. are requiring students to participate in research, and so we have these participant pools or student research participant pools that are an integral part of the research process in the universities. And so the Department of Psychology or faculty management are putting together these pools so that research can be done at the colleges. And so most of these student participant pools, are set up and administered according to good practices so that standard research ethics such as conflict of interest, consent, confidentiality, things like that are appropriately managed. The purpose of this guideline is to bring out the relevant research ethic issues and provide good practice guidance for the management of student participant pools. These should be designed in a way that manages the potential conflict between instruction and research. The faculty does not have undue influence over students, and that the students do not have a diminished ability to give free and informed consent. It also helps to ensure that students do not feel undue pressure to participate in a study. Research should not be required. Students should be offered an alternative to participation in a study that's both comparable in terms of the amount of time and effort required, providing a similar learning outcome. Some kind of alternative to meet these criteria, is providing a walkthrough option. So each participant in a student pool results in a relevant learning outcome. Participants should be followed by a complete debriefing, which includes a pedagogical component that explains the design of the study. In writing such debriefings, a researcher should try to strike the right balance between providing a clear, plain language explanation of the study and introducing the technical terms in a manner that actually teaches them. You want to help students make the connection between the study that they participated in and the abstract concepts that they're supposed to learn. It's good practice for the briefing to be followed by questions about the design regarding the null or alternative hypothesis or independent or dependent variables. The question should be approached as a learning opportunity rather than a test, right? If students have trouble answering the questions correctly, the researcher should continue to go over the points until the students understands. So this is something that we see, like I said, popping up more often across colleges and universities to help teach students the research process as well as allowing research to be done at these schools. And that wraps up the sampling from populations chapter.